In 1994, scientists thought that they had struck gold. They discovered a hormone called leptin, which is made by fat cells, the adipose tissue, and that tells the brain that you have enough energy stored. The excitement was enormous. And they discovered that maybe obesity wasn't about willpower at all, and it might just work by fixing this hormone. If you don't have enough leptin, the solution seemed obvious. Give leptin back, and here you have a cure of obesity. But here's the twist. Most people with obesity didn't have too little leptin. They actually had too much. Their fat cells were pumping leptin in overdrive, but the brain wasn't listening. This condition is called leptin resistance. This crushed the dream of a simple cure, but it also revealed how much deeper and how complex the obesity story really goes. What leptin does in the body is important to understand. It's called a satiety hormone or fullness hormone. Its job is to regulate long-term energy balance. When fat mass increases, leptin increases. Ideally, your brain should hear that signal and say, we've got enough energy, plenty of energy, stop eating, start burning. When fat mass decreases, the leptin drops. The brain responds, we are low, eat more, save energy. Think of it as a thermostat of appetite and metabolism. But what happens when the thermostat breaks or doesn't work? Let's understand leptin resistance in detail. In obesity, this thermostat malfunctions, the leptin. More fat releases more leptin, but the brain keeps becoming resistant to its message. The brain thinks you are starving even when you are not, even when the energy stores are high. So what does that cause? Constant hunger, weaker fullness signals, more fat storage. It's like having a broken smoke alarm. The alarm keeps blaring, but the fire department ignores it because it's gone off too many times before. The signal is there, but the brain has tuned it out. This is leptin resistance, much like how we understand insulin resistance. A real-world example is I once had a patient who said, I don't understand it. I eat until I feel stuffed, but an hour later, I'm hungry again. How does that happen? This is leptin resistance in action. The fat cells were shouting, we are full, but their brain wasn't receiving the message. Instead, cravings and hunger kept driving them back to eat more, deepening the cycle of weight gain. Research shows the modern Western diet, the calorie-dense, ultra-processed foods, damages the very neurons that are supposed to hear leptin's message. That means the more junk food you eat, the weaker your fullness signals become. Over time, your body just stops responding to it. But we can't lose hope. Leptin still holds promise. Even though the first wave of leptin enthusiasm fizzled, researchers haven't given up. In fact, leptin may still offer the next big breakthrough in management of obesity. They are working on figuring out a way to combat this leptin resistance. If we can restore the brain's sensitivity to leptin, if we can restore the damaged leptin-receiving neurons, if we can address that resistance part or design drugs that amplify the effects of leptin, we can have a very successful breakthrough in management of obesity by resetting the body's natural satiety system. This would mean fewer cravings, stronger fullness signals, and healthier weight regulation. As we understand that this is not a willpower issue, it's again a biological neurohormonal issue. So in conclusion, leptin was once hailed as the cure for obesity. Instead, it revealed just how complicated the disease process is. While leptin resistance still remains a major barrier, science is moving closer and closer to unlocking its potential. And when we do it, it would truly be a revolution. It will truly revolutionize treating of obesity. I hope this episode helped in understanding leptin a little bit more. In the next few episodes, we will dive deeper into the neural piece of, when I say neurohormonal pathways, we have talked about hormones. We'll talk a little bit more about the neural piece of this pathology before we can talk about the medications that are making the headlines today, like Ozempic and Mounjaro. These drugs don't fix leptin resistance directly, but they work on the related hormonal pathways and the satiety pathways. Their success just shows us how powerful hormonal regulation can be in management of this disease. Thank you.